This is the ROS Developers Podcast, episode 107 from Kyoto.
The ROS Developers Podcast, the ROS Developers. The ROS Developers Podcast, the ROS Developers.
Hello, ROS developers, and welcome to the ROS Developers Podcast, the program that gives you insights from the experts about how to program your robots with ROS. This is Ricardo from The Construct, and today, we are recording this podcast episode from the beautiful city of Kyoto in Japan because I have attended here for the ROSCon, the official ROS conference. There's the worldwide known conference about ROS and all the world related to ROS and programming robots with ROS. So I am here taking this opportunity to record a special podcast episode, and you are going to see in a minute about who is. Well, actually you already know because you have read the title of the podcast, so you already know. But anyway, if you are attending the ROSCon here with me, then this episode is dedicated to you. So what else? What can I tell you? Okay, so in this ROSCon you will see, if you check the proceedings of the ROSCon, you can see that there are a lot of talks and presentations and even a workshop related to the OpenRMF. The software, OpenRMF is the software created by Open Robotics in order to manage fleets of robots. So it's getting very, very important and very interesting here in the ROS community. So important and interesting that the ROSCon is dedicating a lot of space to it. But so what I want to tell you is that in case that you are interested, we are delivering a workshop. It's usually once per month, which is delivered an online workshop, an online training about how to program robots with OpenRMF. You can check all the details in the web page description that is beneath here on the show notes, so you can understand when to attend. I think the next one is between 2 weeks and 3 weeks from this podcast when it's been released, this podcast, so you can check it afterwards. So it's a workshop where we are teaching how to program the robots with OpenRMF. You are going to be using simulations, you are going to be using also real robots. We have built a complete cafeteria which is run by robots, and then you will learn how to organize all them, how to coordinate, how to make them work together in order to deliver the coffees. You can do that remotely, even from your location. You don't have to travel to Barcelona, where our cafeteria, robotic cafeteria, is there. So check the descriptions of the notes for more information and let me know about it. Well, now let's go to the important stuff, which is about the interview that I have today.
Yeah, let's do it.
Now, let me introduce you Tomoya Fujita. Tomoya is a senior researcher, ROS and Cloud Native Software researcher at the SONY US Lab. There, he works to develop ROS systems. Today, he's going to explain us everything about his project and his research and development at the SONY US Lab. Welcome to the podcast, Tomoya.
Thank you for having me.
Pleasure. Awesome background that we have, right?
Yes.
It's awesome.
Looks
we are here
nice.
Located at the ROSCon 2022 in Kyoto. Yes, and
so nice.
we had the chance finally to meet and to have some questions.
It's so nice to meet in person.
Yes, again. Great. Then I have prepared those questions, and let me go with it.
Yeah, okay? Sure.
Then, so I mentioned that you are working at the SONY R&D Center, US Lab. So what is this? What is it about, and what is its purpose?
So our purpose for R&D Center is to provide a base system So we work with mainline, and we have some feedbacks from the business units. And based on that requirements, we develop our features to the mainline, and it will be ready for the products. So that's the basic, process that we take. So yeah.
Okay. But then the work of the lab is only about robotics?
You mean?
It's so the research that you're performing at the Sony R&D lab is only about robotics?
No, we do many stuff. So the robot operating system is one of thing, and we also working on like Sony proprietary system services, and also as open source perspective, we work with cloud native foundation, for example, Kubernetes, and applicate how it's also open source, and we disclose some documentation about how we can apply the Kubernetes aspect to edge IoT devices. So that's what we do. So we do have many aspects to support, because the products that Sony has is not only robots. So
Yes, exactly.
audio visual and some medical devices. So that's something we have to support with our R&D perspective. Yes.
Okay, great. Then, so what about the robots that you have there at your center? Do you have robots at the center?
No.
Not many. Okay.
It's actually. Oh.
So I don't know.
Okay, that
What
accident.
happened? Yes, that's
Yeah.
an accident.
Accident.
We'll put this on the on the reels, the bloopers of the podcast. Okay.
Yeah, so it's kind of weird, but we don't have any robots on site in US laboratory, because the lab in US is pretty small, so we don't have like many members in that office. But back in Tokyo, we also have many members, of course. So we have Aibo, Poiku, the other robots that we have on site.
Okay.
Yeah.
Okay. But then, how do you test your programs if you don't have any robot? How do you perform the test?
The software layer I have been working on is most likely like a system layer, so it does not require that hardware device. Most likely. So yeah. So
Because it's based on infrastructure for robots.
not more like operating system. So
Yeah.
So it does not require any hardware. So we can develop our software as a low-level implementation and verify our code without any hardware. So it's like a pure software that we work on. So that's why we don't have any hardware device.
Okay.
Yeah.
Okay, I understand. Then the one, just some brief question, curiosity. So one of the robots that Sony has developed and that is using ROS is Aibo robot.
Yes.
Right? And then it's, Aibo robot has been already on the market for a couple of years at least. And so far as I know, it was working on ROS 1.
Yes.
And then the current version also work on ROS 1, or are they going to work on, do they work on ROS 2? Any plans for that?
Yeah. So as you mentioned, currently we have Aibo with ROS 1, and I think the source code is disclosed. So it uses ROS 1 kinetic, and the question about the plan that we proceed to ROS 2 is we don't have any plan. So probably we are not going to do it. Yeah.
Okay.
But I mean, it could work. I mean, if we can push the basic system using ROS 2, of course, I think it's doable.
It's doable.
Yeah. But so far, no plan.
Okay. So I'm very passionate about Aibo robot because it's the one with I did my thesis, but the version of the 2005, and I'm curious. I think that it was like like a pioneer, in the robotics world, because at that time,
Sony was a pioneer.
Yes, it was the pioneer. It created a
Yeah.
OpenR. It was actually a ROS system, more primitive, but it
Yeah.
was the same idea, and it was awesome. Then also in my heart, I have this. I would like to see Ivo, that to be at the edge also in every.
Yeah.
That's why I'm asking about this. But let's go to the other projects that on robotics that Sony is working on. Maybe, or that are using ROS, or maybe not using ROS. Any other projects?
Yeah, so 2 days ago we had the keynote speech at the ROSCON JP 2022, and we had announcement about the new robot Poik that's also based on ROS 1.
Oh.
So the most of the components come from Ivo because of the portability. I think that's the one of the feature that provided by ROS, because we have Node and it can be used to anywhere. So that's what we did. And also we had announcement that Sony drone AirPeak S1.
Oh, yes.
So it also uses ROS 1.
Okay.
Yeah.
So it's a drone that works on ROS. I think that
Yes.
at present there is no drone that works, as far as I know, because I did some research some months ago, and there was no drone working on ROS in the market. Is it? Do you know? Any idea?
I'm not sure, but I think there are some.
Some
but
already?
I'm not sure. Yeah.
Okay. Okay.
But at least the AirPeak S1 is the ROS 1.
It's working with
ROS
ROS 1.
1, yes.
Okay. Okay. Yeah. In case for all of you that are interested on those products, the Puig and the RP, what's the name of the
S1 drone, AirPeak.
AirPeak. Yes. So I will put the links on the show notes. Okay. And then, so in the center, or in the research center that you're working on, so it is advertised that you are contributing with some features to the ROS2 community. So which
Yes.
are those contributions?
Recently, we have we have developed a new feature called the content filter, and that's the brand new feature which ROS 1 does not have any concept of it.
Uh-huh.
So the reason that we have been working with mainline is we have to be ready when that business units try to develop a product. And if we work with the mainline, we can share some like cost with maintenance, this kind of stuff. So we work with mainline to put everything back into mainline, and when the time comes, we could use just the mainline to develop our like application. That means the products.
Okay.
Yeah, so that's why we got a bunch of connections, so the business units. So we have discussion internally. Hey, what's going to happen in like 3-4 years, and what is missing current like ROS2. So we have many discussion internally, and then we will have discussion with Robotics and other members in the community, and hey, maybe this could be something, and can we work together, maybe do collaboration, something like that.
Okay. And in this process is where you got into collaboration, for example, with Proxima, I think,
Exactly.
For the content filter
Yes.
topics. Can you tell us about what is this content filter topic feature?
So the content filter is like, for example, like like a publisher subscribe architecture. Your application will subscribe some topic, right?
Yes.
And let's say that topic is kind of like a sports. Okay, I subscribe a topic, the sports newspaper, right?
Okay.
So once we subscribe the topic, you're gonna have to get the data.
Yeah, exactly.
Yeah. So
all
the
the
data
time.
comes automatically.
Yeah.
There is no rejection. So you have to get the data even if you don't need it,
Uh-huh.
and you have to open the package because you don't know what's in the package. And then hey, today's newspaper is baseball. Well, I'm not interested in the baseball. I want the basketball, right? So you just throw it away.
Yeah, okay.
That means in the computation, you will send the data using network resources and
Yeah.
use computation to read the data and just drop.
Yeah, and the
So-
callback.
Yeah.
You,
Every single time the
Every
message comes in. So it's just a waste.
yeah.
So it's it's okay if you can accept that requirements, but once it comes to the edge IoT environment, maybe we don't have enough network resource.
Yeah.
So why not just hey, that like ability to say, I want to receive only the articles about basketball. So in that case, the sender knows that hey, today's newspaper is baseball.
Yeah.
So I'm not gonna have to send this message to you.
So it's filtered per specific subscriber then?
Yes.
And then this information, it's configured in the publisher.
Exactly. So the API is exposed to the subscriber, and then after you create the subscriber, you can use this content filter API. Hey, and it's really flexible. You can write the description like SQL.
Yeah.
So you can just specify. You can have the data within the specified data range. So it's really flexible, and the API issues on the subscription.
Okay, awesome. Yes, that's a very good point, because it looks like we have all the computer power of the world to do our robots, but when you put into practice, into real
Yes.
product, that's not like this. You have a scarce resources.
Yeah.
You have to save in every time. Okay, that's very good. But that feature about content filtering, topic filtering, it's for ROS 2 or ROS 1?
It's only for ROS 2.
ROS 2.
Yes.
Okay. Okay. And that is one of the contributions, right?
That's one of the major contributions that we have been working on last year.
But I think that I read some others contributions is on the fast DDS shared memory, for example.
Yeah, the shared memory project was the first one. So I think we had the presentation about shared memory with eProsma 2019, if I'm not mistaken. So we have decided to work together. So, but I mean, like as a history,
Okay.
we already have at the moment like only shared memory transport internally. That's our proprietary library, and it's really small, and it's not DDS.
Okay.
So we did actually confirm that using RMW interfaces, we can use this library, and that's okay. But the only shared memory, that could be constrained, because we cannot use the network publisher subscriber. So if we create something DDS aspect with shared memory, it just works out of the box for our use cases. So that's the basic idea. So I brought this idea to ePros Miami, and he said, yeah, that makes sense, and maybe we could work together, and we just did it. Yeah.
Okay. I think that there is also a presentation about this in one ROSCon.
Yes.
In Roswell. Could it be Roswell?
Crossword, yeah, I think so.
I think it's, yeah, because it was during the pandemic that you
Crossword 2020.
2020
Yes.
20, I think. Okay, yeah. So I will look for the specific link and then post it there on the show notes here. I will look for it. Okay.
Thank you.
Yeah. Okay. Okay, great. And okay, something else that you are working in at SONY. You maybe not directly, but SONY Research and Development Lab is SONY US Presence.
Presence, yes.
Yes. What is this?
Presence is the much smaller the IoT device. It's like a microcontrollers. So the Presence that works on NATX, and what we have done is ROS2 works ROS2 work fine, but once it comes to the microcontroller, we cannot deploy the ROS2 runtime.
Okay.
So we had this presence, and there are many activity about micro-ROS. So we just went with the micro-ROS members to enable the micro-ROS on NATX with this presence.
What is NATX?
NATX is IoT. It's like a free RTOS, Not ours, real-time operating system. Yeah, for the microcontroller.
For microcontrollers.
Yes.
Okay. So now you are allowing to execute micro ROS inside this.
Expressions?
Yes. Okay. So Expressions, what is exactly?
Expressions is the microcontroller board.
Microcontroller.
Yeah, it's hardware.
Okay.
Yeah.
Yeah, and then there you put this operating system,
Yeah.
real-time operating system, and then on top
Micro
of
ROS.
that, micro ROS.
And the application comes on top of it.
On top.
Yeah.
So it's natively talking into ROS.
Exactly.
So when you connect this device, already you don't need any driver for ROS. Everything.
No. So the idea is, like, using ROS2, maybe we can deploy the ROS2 application within near edge devices, but it requires most likely some computation power. Maybe like something like Ubuntu, this kind of stuff needs to be there.
Yeah.
But once it comes to the microcontroller, we don't have any resources, right? Constrained environment. So the micro ROS could be something to address the use cases far edge. Yeah. So that's why we have enabled micro ROS on the Sony Expressions board with NATX.
Wow, that is very cool. This is very cool because now I'm thinking about this possibility. Is, for example, the other day in our workshop was about ROS to control, and then we wanted the attendants, the students, to access our hardware robot.
Yeah.
And then for that we have let's say like a virtual machine that is connected through to the robot, but only at the level of ROS topics. However, they cannot access the quadruped robot that we were providing theirs because it was about ROS to control. So you need to be on the hardware. So you cannot be away on a computer away just connected through a network. You have to be on the computer of the robot in order to be able to launch the controllers there because they need to access the hardware. However, if we had used for the hardware of that robot something like Expressions with micro ROS on it, then just switching on the robot will allow the remote students to receive the topics through the network directly, so they don't have to be doing an SSH directly to the robot. Does it make sense?
Yeah, makes sense.
So that's an application. Yeah.
So the use case, I think that it's about the use case for the micro ROS. So we are trying to expand our platform to support the far edge devices. Yeah. To be aware of the ROS2 world.
Okay.
Yeah.
Okay. Nice. So so that's generating some ideas for me for application that I have to study later. Super interesting. Then I would like to talk about your work on cloud robotics because you have done quite a job there already for several years. But before going into that, so what do you think about running applications for robots on the cloud or on the edge or on board the robot for service system? So do we actually need all those systems for service robots? What is your opinion?
Where I can see that the ROS or ROS2 that could be applied to edge IoT devices, but it's not famous in the cloud infrastructure. And once it comes to the connection to the cloud, the topic changes. I mean, like how I can bridge the ROS or ROS2 network to the cloud infrastructure. But the bottom line is the brain. Based on our architecture, the brain, for example, IOCS, the brain is in the cloud. So we eventually need the cloud computation to connect the application on the cloud. So I think that's really important. And so far, some people trying to address this issue. So ROS to bridge, ROS web, this kind of stuff.
Yes.
But currently, there is no concrete solution, I think. Yeah. So I think. I need to consider that how we can make it happen Yeah.
Yeah, what I'm worried more is, for example, at the level of the product. For example, there were some robots, several robots
Yes.
that were in the past, like for example, Jibo, for example, or Vector. Those, all of them, they needed to have a connection to the cloud in order to work, because
Yeah.
the computational resources on board were very, very low.
Yeah.
But then once the companies, those companies go bankrupt, so they stop servicing. So all the people that had the robots, they have now useless robots,
Useless,
because
yeah.
they don't have. So then I understand the necessity of having to have a cloud for very powerful machines and so on, but then also there is the necessity of the customers,
Yes.
that they are buying a product and they want to use this product for many years, independently of how good is the company going or not, right?
Yeah.
So I
Yeah,
don't know where to put the balance.
Yeah,
of that.
I mean, yeah,
That's-
it's about the balance.
Yeah.
So for our case, we have some like architecture. So for example, like if we touch something hot, we will untouch immediately.
Yes.
Right? Without any thinking. That's
Yeah.
kind of like reflection.
Yeah.
So that kind of like process should be done in the edge, because it's gonna take time if we send the data to the cloud and we are waiting for get the feedback, right?
Yeah.
So it's not gonna happen. So I think it's based on the architecture, and everything cannot be on the cloud, but at some level we have. I think that's kind of like a use case. How much the process can be done on this product, or should be done. Yeah, I think I do agree with you. It's just a balance.
A balance.
Yeah, based on the requirements.
Yeah, and it's difficult to
Yeah.
find it where. Okay.
Yeah,
so many.
we are having fun.
And the good thing is
That's what happens.
Yes.
Yeah, on real time.
in real time. So, what can you tell us about your Kubernetes robotics distributed system?
So the Kubernetes activity is a totally different aspect. So as Kubernetes aspect, the ROS, for example, ROS is just a runtime. So it's inside a container.
Okay.
But the Kubernetes aspect, Kubernetes does not care what's inside a container. It just like orchestrates the container.
Yeah.
So, but the idea that we came to the Kubernetes, a container orchestration, the framework that is, for example, like what if we have like thousands of robots on our site? How can we manage those applications, right?
Yeah.
So we can deal with like 2-3 robots by our hands, but once it comes to thousands, if it scales,
Yes.
there is nowhere we can go, right? So the idea is like, probably we could use some like a container orchestration system to manage to our fleet, and that's the basic concept. And also, as extension, if we use container orchestration, the application can be more adjusted dynamically.
Modular.
No, I mean like for example, like it's not really ideal that if we put all of the application for the robots at one time. For example, like if your robot is in the hospital,
Okay.
let's say the context is a hospital, right? So maybe your machine would talk about medical perspective talk, but if we move that robot to a different space, maybe the context should be changed. So that means the application should be adjusted. So based on the location data, maybe we can redeploy the application, based on the environment. So So I'm just saying in one word, the edge IoT, especially the robotics system, is not anymore like static. So it should be more circularly functioning system, just like what we do.
Okay.
Yeah, because for example, we use smartphone, right? We install the application when we need it.
Yes.
So that should be done by robots.
Okay.
Yeah.
Okay, and then when you are talking about installing by using Kubernetes, you are thinking more in the from the point of view of managing fleets of robots,
Yes.
but not on the point of having smaller applications, which is the typical use of Kubernetes, right? It's like the microservices.
Yeah, exactly.
Yeah, but that's not possible to be done in robotics applications, especially ROS, because every application requires so many things, so that the micro label goes away completely because it's a Docker with several gigabytes. So that's difficult to deploy. I mean, it takes time, so you cannot do it live because it takes time. Microservices, the advantage is that you can start and stop very, very quickly as you need it, but not in the case of robotics applications, I think.
Yeah, I mean, like it can be addressed. We can probably divide into some, I don't know, like context, maybe the perception container or something. At some level, we can divide into some containers, and that can be reusable to any, like as long as it's container.
Yes.
It can be reusable. So I think that can be done.
Yeah. So it's of course it's a container, so you can relaunch. You can, for example, let's put the navigation system of the robot in one single container. But what I mean is that this container, as far as I have tested, is a very long container, large container.
Large container,
because it's several gigabytes already with everything that you need in there.
Yeah.
So deploying this in terms of microservices is not possible. Then the cloud-based Kubernetes system is more for not for allowing start-stop services as needed, but to deploy to multiple robots the same application, the same updates in an easy way.
Yeah.
That's what my question, if I have correctly understood.
Yeah. I think your understanding is correct.
Okay.
So but the point is, first we want to manage our fleet, and second point is like we think about application engineer, because they don't want to care about the platform.
Yeah,
right?
that's right.
If I am the application, I actually don't code for the application. I'm mostly working on the systems, so I don't do application development. But if I am the application engineer, I don't care. I don't want to know anything about platform. Hey, this is my application. You take it and you run. Right?
Okay.
Because I care about application logic.
Yes.
But what happens right now, edge IoT devices, we have to integrate the application every single time when the platform changes. For example, vendor A, vendor B, vendor C, blah blah blah.
I see.
The application is like almost same. Let's say like a speech recognition or something, but application is almost same, but every single time we have to integrate that speech recognized application for each platform.
Different device.
Yes. But I don't want to do it. I mean, like if I'm an application engineer, I don't care. Right? This is a container, and it requires 4 mics. That's it.
That's it.
Everything else should be taken care of by the system perspective. So that's something we want to do.
Okay. That clarifies a lot. Yes, makes perfect sense. Very good. And then, so what is this current status of your Kubernetes robotics distributed system?
Yeah, so we have been working on that maybe probably 2-3 years. First, I gotta say that Kubernetes is a huge framework, and it's really famous as de facto standard in the cloud native application engineers.
Yes,
everybody uses a big player. So, but it does many stuff. So I think it's really hard to understand what is going on in the Kubernetes as system perspective. That was really pain. But now we have been working on some POC. We also have some trial using ROS2, and so far it works okay. And as I mentioned before, the runtime is not only for ROS 2. So we have been working on something else, using like video streaming, this kind of stuff, using container orchestration. So now, it's pretty much ongoing task, and it's really difficult because it's really complicated. It's hard to understand what is exactly going on inside a container orchestration. Yeah.
So maybe more debugging tools they are required to be developed.
Yeah.
More, I don't know, reporting tools. I don't know.
Yeah. So there are many debug tools, but yeah, it's really hard because if you deal with like container orchestration, you need to know pretty much about like network and systems and container orchestration. So it requires many
Skills.
knowledge.
Yeah.
So we have been working on that, and as output, we had the speech the last year KubeCon EU about using ROS and Kubernetes. Yeah. That's the current status.
Okay, and now that one question pops into my mind, which is you mentioned that you don't have robots. So how do you test all these things in robot? Do you have some other partners that are doing the testing on real robots?
Yeah. So like Sony R&D Center, US Lab, just me. But we, of course, I have been working with members in Tokyo. So they have devices, and also sometimes it does not. We don't have to use hardware, so we can just create some, like a operating system instance, and to see if what's going to happen, as a network perspective, or maybe I'm just saying. Sometimes it does not have to be, we don't have to possess the actual hardware.
Okay.
Yeah.
Okay. More or less. I don't know if I would agree 100% with that. Because you know that at the end. So in theory, everything works.
Yeah.
But in practice, many times it doesn't.
Yeah.
When you apply to the real stuff,
Yeah. So that makes sense. So eventually we need to verify everything on site.
Exactly.
Yeah, with the hardware. So of course we will do that. But now it's like a POC.
Okay.
We are not there. So
I understand.
we are just
I
trying
got
to
it.
hey, this could work, and we find some problems because the Kubernetes itself is built especially for the microservices in the cloud,
exactly.
right? So they don't care about edge IoT use cases, right? So, for example, network. They know that the network connection is so stable because it should be running in the cloud infrastructure. But if we bring that idea to the edge, network could be fragile.
Yes. Exactly.
So what's going to happen? So this kind of like a use case we are missing.
Okay. Now I understand. Of course. And now I understand your situation. So this is a work in progress, and then you still haven't reached the stage at which everything, the basic infrastructure, the core system is working on, let's say, on simulation, like in a simulated environment. Now it's time to go to the real world and see what happens. I understand. Okay. Yeah, of course, that takes some time to be done, and you have to solve the problems. Great. So let me see. Okay. Then. So let's talk. I mentioned about simulation. So how do these distributed system integrates with simulations of robots? Have you tried?
Not really. So we just confirmed that the simple use case, simple application with ROS 2 and Kubernetes, it's working.
Okay.
But we do have
like a listener talk.
Exactly.
Example.
Yeah, multicast, the DDS, this kind of stuff. Everything should be okay so far. But as I mentioned, we have the other use cases like audio-visual system and more different edge devices. I mean, different here is like it's not robots, consumer devices. So we have many use cases, but this Kubernetes idea is can be applied to anything. So we have been working on something like that.
Okay.
Yeah.
Okay. Okay. So let me see. Let me
So
say, yeah. So yeah,
squares.
because yes, and
see.
also many of the questions already we have discussed. Not a specific question, but so I'm checking my questions here on the screen. So yeah, so about this framework, is it open source? So can we download it and test it?
Of course,
ourselves?
the open Kubernetes is the open source.
No, but I mean your environment, your your Kubernetes robotics distributed system.
Oh, I mean, like we don't develop any proprietary software to do that. We just use the open. Everything is open source. So we don't have any software developed by us.
But then, so how can we test your ideas? So what you have already implemented, how can we test it? If
Oh,
we
it's
want?
yeah, it's hard to explain, but the point is that we just use the open source, the framework, the Kubernetes, the other stuff,
Yes,
and that's it. So
but you have to have kind of a infrastructure description.
oh yeah,
files.
So, yeah. So yeah, I got it. So if you want to use Kubernetes with ROS 2,
Yeah.
you're gonna have to write the description.
Yes.
So that description means that hey Kubernetes, I want to deploy
Exactly.
the ROS 2 application there, here, and this is the application code, and this is binary. Binary means the container image.
Uh-huh.
So that's something you have to set up. But nothing else. Just a YAML file and the container image.
Yes.
Yeah.
Yes, because this YAML file is the one that is specifying the infrastructure that requires to be launched, and also the communications between the different containers or something like that.
Yeah. So if you want to use ROS 2 with Kubernetes, you have to deal with the container network interface.
Yeah.
So, and so far we tried to use Weave implementation, and it works okay because it supports the multicast. That means like a DDS discovery can work. So, yeah. So, I actually have uploaded the YAML file on the GitHub. So that's something you can see. Yeah.
Okay. And then people, so it's because in our audience there are a lot of developers, and then the point is that they want to try many times.
Yeah.
So I can point them to your Git,
Yeah,
and then
sure.
they can download this YAML file,
Yeah.
and then try to deploy.
Yeah,
your-
it's not a big deal. It's just a YAML file to tell the Kubernetes, hey, this is my
Right. How?
free to control, and you do it or something. Yeah.
And is there any documentation that they can follow in order to replicate your results?
Not really. I don't think we have documentation.
Okay.
Okay. Yeah, but I mean, like you need to understand how Kubernetes works. I think.
Okay. Yeah,
With-
that's a must.
yeah,
of course.
without acknowledge, it's hard to control.
Yeah. Of course. But then, I mean, so you have done. I have seen your presentations, and you have done a lot of experiments and a lot of examples. But how can they take those examples? Is it possible to replicate those results that you have shown?
Yeah, so the result pretty much that I have is YAML file.
Yeah.
It's
Yeah.
not a big deal. So
Okay.
yeah, so nothing else. Maybe the container image can be also shared, but it's not a big deal because
Okay.
that's what I think that everyone does every day because most people use container.
Okay.
Yeah.
Okay. Yes, they know.
Yeah.
Most of our developers know.
Yeah.
And in case that you don't know, at the Construct we have a very nice course about how to use Docker for robotics. So you can go there. That's a small commercial in the middle. And in case that you have more questions about this Kubernetes robotics distributed system, maybe they can contact you directly and
Sure.
ask you questions
Yeah.
and suggestions, of course. Right?
Exactly. So
Okay.
yeah, we have been working on that, but we would like to share more information. And if you are, for example, use cases, Yeah, so I think that's really important to share as community.
And I'm worried about one thing. So you mentioned this distributed system that you are using with Kubernetes is for ROS 2, right?
Yeah.
And then, well, I know that when you are using Dockers, then networking between the different Dockers, if you want to pass information, I mean, it's a little tricky. You have to do it right, and especially in ROS, because ROS requires network communication between the different applications in different Dockers, and so how does it work? Is it managed? Do we have to take a special care for that when launching in Kubernetes?
Yeah. So after Kubernetes launched, you need to deal with container network interface.
Yes.
So because the basic idea that Kubernetes has is like isolation. So hey, application engineer just cares about the application logic. For example, database, nothing else. And this case, application engineer does not care even about network, because network should be handled by network perspective. So there are many isolation. For example, like container storage interfaces, container network interfaces, and so this is flexible because there are many use cases. This is intention to support many use cases, so that, in other words, the user can plug in their own implementation even. So yeah, there are so many stuff to explain.
Yes.
Yeah.
I know that then, I mean, this is just a podcast on the high level.
Yeah.
So we are not going into details about that. It's not possible. That would be require a class, like a class. So it's just to explain to the audience what is the work that you are working, and then they will get interested, and then they will start finding more information and ask questions to him. to him. Is it possible to use? Have you tried doing any experiment about launching ROS 1 bridge in order to have different applications running at the same time, ROS 1, ROS 2, they communicate inside this Kubernetes?
No, not really. So we have. I think it should be work. It should be no problem. I mean, like because the application, as I mentioned, the application container is not aware. Technically, is not aware the network interfaces. It just sees the network interface, and if it can connect, that everything works okay. Yeah, that's the way it is. So, but we have never tried, but it should be work.
It should work. Okay. Yeah, it makes sense.
Yeah.
It makes sense. Okay, then let me ask you another question about another project which I saw recently that you have presented. It's called SRT, Prometheus Exporter. So what is that about, and why is it important for the ROS community?
It's not for the ROS.
It's not,
It's not
but
for
you
the ROS.
presented with what's another ROS company?
Discourse?
Discourse. Okay, so
I don't know where did you pick it, but the SRT project is we have released some paper to describe the overview, right? But it's not for ROS.
I know.
Yeah, it's for
what
SRT.
is about now that we are curious now.
So the SRT, I think that topic can be off from the SRT,
Okay.
but the point that the idea comes from the statistics. I think the eProsima had the presentation, I think yesterday.
It's a Proxima.
eProsima.
You were presenting this with a Proxima also. Yes.
So that we care about statistics.
Okay.
So, for example, like using ROS2 or DDS, eProsima Fast DDS or something, we need to check the statistics based on what's going on, right? Each endpoint. So we can see that based on the statistics, we can adjust to the environment. For example, like if your network is unstable at this moment, you can see that we are losing packages, right? We can see that activity based on the statistics, and we can get that statistics every single endpoints. And there are some application. We need to adjust the parameter.
Okay.
So that's the basic idea.
Okay.
Yeah.
I see. And then the Prometheus is like
Prometheus is just a collector.
it's a collector of
Yeah,
data.
it's really famous in the cloud native technology, and I think that most of the vendor running in the cloud infrastructure, they use Prometheus to collect the statistics. So because they use the microservices, so it's like a circuitry functioning system. So based on the statistics, hey, I need to redeploy this application somewhere else, or we need to adjust the specific parameter for this endpoint.
Okay. Yeah, now it makes sense. Well, actually, in robotics, those statistics is very important also for knowing what is happening.
Exactly.
Not even in terms of failure, but also in terms of understanding what is, for example, getting. So there are many requests to a certain device there that shouldn't be there. So you can catch some kind of errors by doing those statistics inside the robot itself.
Exactly. So the many framework, let's say the libraries, maybe they have like API, right? API to access the statistics data. But I don't think that's enough, because the user does not know how to use it. Because hey, in that case, the answer is, hey, there is an API, and you call it and use it, right? It's not really useful. So the Prometheus is like, hey, I can collect any statistics from every single like endpoints. And if you want to access the statistics, and you can access to the Prometheus, see what's going on right now. So, and you can even specify the specific endpoint and specific statistics. So it's easy to read from user perspective. It's more useful, right?
Because just watching numbers.
The user perspective, hey, I want statistics. Hey, the answer is access Prometheus. You can do whatever you want.
Okay, that's very interesting. I'm going to put the link also to Prometheus for you, ROS developers listening to the podcast. But also, I'm going to check the Prometheus is, because it looks very, very interesting. Okay, then we are about to finish the interview. So I would like to know more about your work for the ROS community. And so you have been working on you mentioned before, on the FastDDS shared memory project. So can you share more about where did you work in there?
So the first DDS shared memory project is completed, and the content filter, I mean, like to the FastDDS perspective, which is already completed. So now we have been working with fallback filtering. So this is it's like concealment for the API. So currently the FastDDS supports content filter, but some other implementation they do not support content filter. In that case, the ROS2 application perspective, if we call that API to content filter, sometimes
it
will fail. So that means the application cannot be consistent. So that's our concern with Open Robotics. So we already have the draft PR, which is huge in the GitHub, and we did implement in the RCL layer to if the RMW implementation does not support content filter, okay, we can do the filtering on the receiver side in the RCL, so that application can be consistent.
I see.
I think that's mandatory. We have been talking about this with Open Robotics. So but to think about the ROS user, I think this is mandatory.
This is mandatory, and it's a very, very good point. I didn't realize when you were explaining about this that it's only for one specific implementation, the content filtering of DDS. The content filtering only for one specific implementation of DDS. Then this, if we don't take care of this, it could happen like with the browsers in the Internet Explorer era. You know that there was the HTML standard, but then of course Windows, Microsoft was trying to to get the control of this. So we started to introduce some other very cool features in the HTML, but only if you use Internet Explorer are supported, because there's, so that make that some pages, web pages, were not properly rendered unless you use Internet Explorer, you know. So, and then it's kind of make it break the standard. And then in this case, that would be that if you create a application only for content filtering right now, but your robot doesn't have this FastEDS as implementation, then it will crash somehow.
Not crash, but the currently that responsibility goes to the application, because we have to return fail, right? Not not supported.
Exactly.
Yeah, so the application needs to check, hey, implementation, do you support the content filter? And if it says no, that's comes back to the application responsibility.
Okay.
Yeah.
But
so
then still the application can get the data from the topic?
of course.
Okay.
But
okay,
no
okay.
content filtering.
Yeah, not content.
Yeah.
Okay.
But I'm saying just the application code could be complicated.
Yeah,
right?
yeah, a little bit more complex.
Yeah.
Okay.
So
okay.
as
It's
Rust,
not crashing and it's still running.
Yeah. As a Rust user, I don't want to care about that.
Yeah,
so
exactly.
just let me issue the API.
Yeah. So it makes perfect sense. Now I understand. Very clear. Then, okay. And then, so final question is that you are a member of the technical steering committee for ROS 2, and what is your role there? Can you clarify?
Yeah, mostly I just work on technical, especially like a middleware not implementation interfaces and RCL and the client RCL C++. So, yeah.
But what's your role? What are you doing at this steering committee? Are you like proposing or checking proposals or?
Yeah. So what we do is if we make decision about distribution about default RMW implementation, we will discuss about how we want to proceed to pick which implementation as default. And also, for example, there are many issues in the core system. So we have been working on discussion how we can address these issues. And it's impossible to, just us to go through these old problems. So the discussion is more like how we can, bring the people to the community and to do community review and researching the issue, this kind of stuff. Yeah, but basically my perspective is like a technical and a middleware low-level implementation ROS2 core. So I think that's my role.
And how does it work? So does it work like the United Nations, or how? So do you vote? Do you discuss? How do you decide things? Because I'm telling you that because from outside we are the ROS community. Okay, so we are outside from the technical steering committee, and then we are interested to see what is happening in there. What are they discussing? What they are?
Yeah, but I think they disclose the meeting note.
Yes.
Yeah.
And also the videos.
Yeah. So I think that's pretty much about it.
Okay. So the answer would be that the audience, they can actually go and attend the meetings or even watch the videos because they are publicly released.
I'm pretty much sure that every month we have TSC meeting.
Yeah.
And the note, the memo is disclosed every month. So if you are interested in the activity that we have, you can definitely check those out. Yeah.
Okay. It was it's a last question about something that is not technically directly. I mean, it's not about development, but it's about how the ROS2 is evolving. So how they're taking decisions and the different. That was the purpose of this question.
Yeah.
For curiosity. Okay, so guys, that's all. Thank you very much, Tomoya.
No problem. Thank
Thanks
you.
a lot.
Thank you for having me.
My pleasure to see you again, to meet you in this awesome environment, even if we have some interactions. And
That's all?
that's
I think
all.
so.
So thank you very much, audience. See you next week with another lesson from the experts. And until then, keep pushing your ROS learning.
Thank you.